This is day 4 of Advent of Code 2025. This challenge is called Printing Department. You ride the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of large rolls of paper everywhere. There's even a massive printer in the corner to handle the really big print jobs. Decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole base while the elevators are offline. Actually, maybe we can help with that. One of the elves replies when you ask for help. We're pretty sure there's a cafeteria on the other side of the back wall. If we could break through the wall, we'd be able to keep moving. It's too bad all of our forklifts are so busy moving those big rolls of paper around. If you can optimize the work the forklifts are doing, maybe they would have time to spare to break through the wall. The rolls of paper, the @ symbol, are arranged on a large grid. The elves even have a helpful diagram, the puzzle input, indicating where everything is located. So for example, we have this, all the @ symbols are the rolls of paper, and then assume the dots are free open space. Forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. If you can figure out which rolls of paper the forklifts can access, they'll spend less time looking and more time breaking down the wall to the cafeteria. So in this example, there are 13 rolls of paper that can be accessed by forklift, marked with X. So it said fewer than 4 in the 8 adjacent positions. So what does it mean by that? So, okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. So it's all the spaces around it. So this one is marked as X. So it only has 1, 2, 3. And okay, so fewer than 4, so 3 or less. This one has 1, 2, 3. This one has 1, 2, 3, 4, 5. This one has 1, 2, 3, 4. Okay, that makes sense. So consider your complete diagram of the paper locations. How many rolls of paper can be accessed by a forklift? Okay, that makes sense. So we'll grab this input, head on over to here and paste that in. And we'll need to do some playing around with our input here. So we've got the rows as strings and we'll need to create a grid out of it. So let's do int height is equal to input.count, and then int width is equal to input 0.length, and we'll do int output is equal to 0, and we'll update this to have that there. So what we need to do is go through every single cell within this input grid and figure out how many of its neighbors have the @ symbol. So, or I should say, we first need to find if the cell we're looking at is the @ symbol, and then go through. So this will be just 2 for loops. So int y equals 0, y is less than height, y plus plus, and let's grab the row from here. So input equals y, or the y index. Then we'll do for int x is equal to 0, x is less than width, x plus plus, and then let's grab car cell equal to row x, and we'll do if cell does not equal to the @ symbol, we then continue. So then we find the next one. So if we're past this point, we now know we have the paper roll, and we now need to search in all directions around it to see if those are also paper rolls, and we're wanting 3 or less. So let's do int neighbor count is equal to 0. And one way we can do this is a for loop for the y-axis. So you've got your current y, and you can do for loop. So -1, 0, 1, and then a for loop for the x. So this would be -1x, x plus 1x. So we do a for loop like that to get all possible positions. So for loops from -1 to 1, and just adding it onto what our current x and y is. So I'll say for int neighbor y is equal to -1, neighbor y is less than or equal to 1, neighbor y plus plus, and then we will do exact same thing here, but this will be for neighbor x. So neighbor x, neighbor x, neighbor x. So then we now need to use this y, this x, along with this y, this x. It's just a current y is equal to y plus ny, and then same thing here for current x is equal to x plus nx. So before we actually look at the cell, we need to see if it's within the bounds of the actual grid. So if current y is less than 0, or current y is greater than or equal to height, then also I'd do the same conditions for the x, current x less than 0, current or greater to width, the name those correctly. If it's outside the bounds of the grid, we then just continue. And now that we've done that, we do if, what are we looking for? Input current y, current x, and we put parentheses around it. If this is equal to at, and we do neighbor count plus plus. And what we do here, so once we're outside of this for loop, if neighbor count is less than 4, and that is output plus plus. So that should be all that we need to do for it. So let's run it and see if we get the correct output. It's giving 4, which is not right. It should be 13. Okay, let's do console.writeLine here to see what coordinates we are on, and hopefully we can clearly see from that where we've gone wrong. So let's put that out. So 6, 2, 0, 7, 0, 9, 8, 9. So that would be 1, 2, 0, 1, 2, and 0, 1, 2, 3, 4, 5, 6. Apparently this one, that is correct, but it should, maybe I did something wrong here. Maybe to simplify things, I'll break this part up to like this. So I don't have to check the condition every time. Okay, so we check on the y, then we check on the x. Yeah, looking, so we've got x0, y9, which will be this one. That has one neighbor, which has the at, then 8 and 9, which is this one, which is one neighbor. X0, y7, that is 7 neighbors, 2 neighbors. So maybe must be a condition wrong where maybe I need to add another condition to here so we can more clearly see what's going on. So we've got that, what neighbor count, if that's working properly. And maybe I'll also include inside of here. Okay, so it's saying neighbor count 3 for this one. So maybe what I should do is just print this in general, and we can find a coordinate and see what it had. So which one? So let's say 2, 9. So 2, 9 apparently has, okay, that makes sense, because within here we're not actually checking to see it's including itself in it, which it shouldn't. So let's do that. Or x is equal to current x and y is equal to current y. Should add that condition in. So now that should work. 13, there we go. So we'll now go grab our actual input and paste that in and run it. 1553. Is that correct? And it is. So we'll now go on to part 2. Now, the elves just need help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklifts might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the elves remove if they keep repeating this process? Starting with the same example as above, here is one way you could remove as many rolls as possible. So you do that, then using this to indicate. So after the one iteration, you remove 13. In another iteration, remove 12. Then remove 7. Then 5, 2, 1, 1, 1, 1. So you keep going until no more rolls can be removed. In this example, you're able to remove a total of 43. So starting with the original diagram, how many rolls of paper can be removed? Okay, so we'll come back, we'll set this back to the original, and let's copy this code to here. Okay, so we're not just running it once now, we need to run it multiple times. So let's do output int, and we'll do current remove is equal to -1. Let's do while current remove does not equal 0, and we will put this in. So we do that for output current remove. Let's change this to current remove, and then down here we can do output plus equals current remove, and if it does not equal 0, we then initialize it to 0. That should work, but we now need to actually update the grid. So we need to actually change our input to be an actual grid instead of just going through the line. So let's do car array is equal grid is equal to input. Actually, maybe we just initialize it as new character array, and should bring that down to here, and we'll initialize it as the height of, or the size of height width. Actually, let's just make this var, then do that, and then let's just do a simple little for loop to populate the grid. So we've got for loop, we grab the row, for loop, and we can do grid y x is equal to row X. So we've now got our actual grid, and what we need to do is go through and change it. So cell is no longer that, it's grid Y X. And what we need to do is, if it can be moved, we do grid Y X is equal to dot, and then it should go through another iteration, and this time it's a dot, so it won't be picked up as a neighbor, and then it should run. So for bugging, making sure it works as expected, let's print out the current remove here, and let's run it. Okay, so it went from 13 straight to 0. Okay, well, I shouldn't do that, so let's maybe do one of the loggings we did before, which was X, X, Y, Y, and then add in the neighbors. Okay, so they are all coming up as 0. Okay, first time I went through, it was working, but then later on, it just all came up as 0. Is it possible I've done like an XY or something near somewhere? No, it's all just YX. Maybe we just need to actually print out what it actually is and see what that comes up as. So there are a lot of @ symbols still, but then apparently all the neighbors aren't. So if neighbor count is less than 4, then why wouldn't it do that? Just adding a logging C. If it's getting removed, it's not getting removed, even though I did current move there, should be looking at neighbor count. That's why. Okay, so this one we can see it's being removed, but let's also verify the values being changed. Do a before and after. So it is changing it to dot, but for some reason it's not actually changing the others. So let's say x1, y1 is 6 here. Well, if we go to this example, this is 1, 1. So we should be seeing y0, I think that's x7, that should be removed. Yeah, y0, x7, that's 4 neighbors still. 1, 2, 3, 4. So in this one, these all got removed, but then in this one, it should be getting removed because there's only 2. Oh, actually, I just realized a mistake. We're changing it, but still going to be double checking those as well when we look at the neighbors. So I can't do that. But to be removed, do something like this. Like the list of int array, maybe. So okay, we'll do that. And down here, we will do dot add yx. Then once first iteration has been done, then we'll do for each bar chord in to be removed. We then do this. We chord 0, then chord 1. So we do that to remove. So keep this, do that. Now let's see what's happening. Still came up as 13. Still using input here. It should be grid. That's why. Forgot to change this one section. There we go. Getting 43. So remove all that and all these loggings, and now we'll use the actual input. Should have thought of that sooner because obviously we changed how we're handling the input. But okay, now getting 8442. We will submit that, and that was correct. If you like this video, make sure to like and subscribe.